So this is the part for 3-4 day 2 that will match your assisted notes that you have. So the first part is just another velocity time velocity graph to get used to some things. So they're talking about a particle, think of it as a particle of anything, moving on a number line. Okay, they're showing the velocity, the speed with direction. So when it's moving to the right, its velocity will be considered positive. When it's moving to the left, its velocity or speed with direction will be considered negative. So on the graph, just so that you know, so the velocity is the derivative of that position time graph. So we're looking at one that's representing the speed with direction for this particle's movement. So when is p moving to the left? So on a velocity graph, you can tell when things are moving to the left or to the negative direction when their velocity is negative. So they're talking about it at different rates, but they're still talking about it moving to the left. So between 30 and 55 seconds on this derivative graph, we see its velocity was negative, indicating it was going the opposite direction. When was it moving to the right? That will be all the times when the velocity was positive. So we're looking at times between 0 and 30 minutes for that. Then it's acceleration. So, by the way, at 30 is when it changed directions. It went from positive to negative, and therefore, momentarily, for that instantaneous idea, would have an instantaneous velocity of 0 at 30 minutes. What's the acceleration? So on the graph, when you're looking at acceleration, you're talking about the slope of the velocity. So that's a derivative. So we're looking at slope. So anywhere that has positive slope in the graph, we're talking about positive acceleration. So that graph of the velocity is showing positive slope between 0 and 10 minutes. Therefore, its acceleration is positive. It's also showing positive slope again from 40 to 55 minutes. And therefore, its acceleration is positive. Anywhere that it's indicating negative slope, so that would be from about here till about here. Okay, anywhere that it's indicating negative slope is when its acceleration is definitely considered negative. So its negative would be between 15 seconds roughly and 40 seconds. And then where is it indicating an acceleration of 0? An acceleration of 0 is going to mean a slope of 0 on the velocity graph. So we're seeing that slope of 0 from a time of about 10 to 15 minutes. Then they're asking when is p moving the fastest. So the fastest that p is moving when you look at the velocity graph is whatever point is the farthest from the x-axis, either the farthest up or the farthest down. So the highest velocity that I see it demonstrating, whether positive or negative, is 60. So when it was at a velocity of 60 meters per minute, it was between the time of 10 and 15 seconds. So when was the point moving the fastest? On the interval from 10 to 15, and we're not seconds, we're minutes. Apologize. All right, the next part does a position time function. So the last one we saw velocity, that was the derivative of a position time function. So they're talking about a different particle moving along a line so that it's positive at any time that time is greater than 0 at a position. And then it's given by this function. So its position is given, times have to be greater than 0, so we're not going back in time. They're letting us know the units, the positions measured in feet, and the times measured in seconds. When they ask for displacement, they're simply asking from 0 seconds to 5 seconds, what was the change in location or position? So to get that, we want to think about, well, where was the particle located at 5 seconds? And then where had it been at 0 seconds? There's no divide by here. They're not asking us for an average rate of anything. They're simply asking us for a change in place or a change in position. So when we go to do this, you'll need to evaluate S of 5. Take a second and do that so that you're sure you see where this number is coming from. So S of 5 is 270, and I got that by just plugging it back right into the S of t function. S of 0 comes out 0, so in the first 5 seconds, from 0 to 5 seconds, it changed position by 270 feet. It's not a rate, so it's not per second. Then it asks us for a rate. It asks us for the average velocity during the first 5 seconds. We already know what the change in position was in the first 5 seconds, which would normally be the numerator for our average velocity or average rate equation. And then we have to say how much time passed. This is our y2 minus y1, so we need our x2 minus x1. So we know it changed position by 270 feet over the course of 5 seconds. So the average velocity is going to be 54 feet per second in those first 5 seconds. Hopefully you can't hear the smartphone jiggling as much as I can. Then it asks us to find instantaneous velocity at a time of 4 seconds. So instantaneous velocity is just going to be that rate of change that we're looking at the derivative then. So we want to take the derivative of the location position function. And once we have that derivative, we'll evaluate it at 4 seconds. So the derivative of that, you know how to get your derivatives. 4t cubed minus 6t squared minus 12t plus 9 to get the slope at any location or the velocity at any individual point. So we're going to evaluate the derivative at 4 seconds and double check, plug that in, and you should get 121, and this is a rate, feet per second at a time of 4 seconds. Then it asks for acceleration. We said acceleration is the derivative of the velocity function. So it's the second derivative of the position function. So going and doing a second derivative means basically from the first, we need to do the derivative of it. So we're looking at 12t squared minus 12t minus 12, taking the derivative using those polynomial function rules. Then it's asking at 4 seconds, what was the acceleration of the particle? So we're looking at using the second derivative at 4 seconds. When you plug 4 into that second derivative, you get 132 feet per second. Feet per second per second, so feet per second squared. So then it asks at what values of t does the particle change direction? So it changes direction when the velocity is 0. Because velocities that are positive are moving to the right, velocities that are negative are moving to the left, so velocities that are 0 aren't moving left or right, it's changing direction at that time. So we're looking at when that derivative function, s of t, is worth 0. It's not a great quadratic to solve by factoring, so we're looking for when 4t cubed minus 6t squared minus 12t plus 9 is equal to 0. For this one, use graphing. You can do the same on your homework tonight. So for this one, when you graph that derivative function to see where it's worth 0, you're going to see 3 mathematical zeros, but only 2 that make sense because it already told us time had to be greater than 0. So this first 0 you see will not work because it said for times greater than 0. So when you graph it, those are the 2 zeros that will be for t's greater than 0. And double check that you can get these. Okay, be at 0 point, and again we're going to round to 3 decimal places because that's what we do in calc. 0.634 seconds and 2.366 seconds. Please make sure you can graph and get those to come up yourself so that you're not wondering how I did them when you get to homework. I have to split the video into 2 parts so that it will mount onto YouTube best, so I'll be back in a minute.